Okay, so my wife wanted a way to let her know if, as she pulled into our garage, if she had enough room to keep going or if she needed to stop. Um, the one solution, of course, is a simple string and a tennis ball, but there's no fun in that, so I decided to work on a Android-based, uh, an Arduino-based setup with the ping ultrasonic sensor. And so basically, um, for now, this is in a prototype stage. But there's two LEDs. Red means stop, and the green means you're still good to go. So if I take the place of the car, you'll notice that right now the green LED is lit, and as I come forward, the green LED switches off and the red LED comes on to indicate stop. I'm still experimenting with trying to give it some hysteresis so that it doesn't keep wiggling on it. The lights keep alternating really fast. I'm trying to work on mitigating that by giving it two separate thresholds. So as you go forward, it triggers, but if you move back, you have to go back a little bit further to then reset to the green. So again, red, stop, back off, then it goes back to green. So that's the hardware. Software, again, is based in Arduino. You'll notice here the software values, and I'll show you how that relates to the hardware here in a second, but it'll give you a warning if it counts a pulse width of 800 milliseconds, and it'll go back off. It'll switch to green LED on, red LED off when it reads a pulse length of 1600 milliseconds. And that you can see up here on the oscilloscope. You'll notice here, let me go in a little bit. What you have here, this very short little pulse right here, that's the Arduino putting out a command signal to the ping sensor to initiate a ultrasonic burst. So that's the output, and they go on the same pin into the ping sensor. So this is output from the Arduino to the ping sensor. A few milliseconds pass and it gets a reading. This is now from the ping sensor back to Arduino, and the pulse width, or how wide that pulse is, varies based on the distance. So as an object is far away, the pulse is wide, and as we move in close, the pulse width gets narrower. Let's see if I can. So again, pulse width when we're far away is pretty wide. Coming closer, pulse width gets narrower and narrower. And the values that you see on the screen are based on, let me bring those up. Those readings are based on the Arduino taking a analog to digital conversion of the length of the pulse. It's counting the pulse, and then that integer value varies, and that corresponds up here to the pulse width. A longer pulse width, like you see right now, would correspond with very large values, nearly 3,000 milliseconds. And as an object moves in, you get the very narrow pulse width, which corresponds to values in the low 100 milliseconds. And So that's about it in a nutshell. Again, simple parking aid. As you back off, you're good. Green LED, get too close. Red LED, stop. And that's about it. I'll throw some other information up on my website, some source code and the schematic. The layout's pretty simple. 2 LEDs, 2 resistors, and then the pins to the ping sensor connected directly to the Arduino. With just there's 3 connections: power, ground, and signal. And that's about it. Thanks for watching.